The reprint problem. Assessing the impact of reprints on secondary market values of Magic the Gathering cards. Magic the Gathering is a collectible trading card game where players build decks of cards to compete against each other in strategic, turn-based matches. It is both a competitive and casual game, and a collectible market. The game has over 30,000 unique cards and 80,000 unique printings. A reprint is a printing of a card that takes place in a set other than the first one that card was printed in, i.e., not the original version. Reprints are intended to make older cards more accessible for players by increasing the supply of those cards in the market. Existing research confirms general price drops for cards after reprints, but there is a bit of uncertainty about the extent to which value changes are actually caused by reprints rather than broader market trends. Which leads us to the underlying problem. Despite being a cornerstone of the Magic the Gathering economy, the true long-term impact of reprints on card value remains largely unquantified as of yet. This uncertainty affects players, collectors, investors, and shareholders alike. This issue is significant, as better understanding the impact of reprints will help players, collectors, and publishers better understand MTG's secondary market as a whole. This understanding is critical as it drives player access and collector confidence, and given the scale and complexity, as well as the value of the game's economy, it can help clarify how reprints influence its behavior. So, the question: to what extent do reprints of Magic the Gathering cards cause short and long-term changes in their secondary market values? Before we get into the methodology, some defined terms. First, reprints. A reprint is a printing of a card in an official capacity that takes place sometime after its original release. For example, take Sol Ring. Each of these cards is a different reprint of the original Sol Ring, seen on the very right in just a moment, and make up less than 1/3 of this card's total reprints. While this is one of the more egregious examples of cards being reprinted at volume, it demonstrates that reprint frequency can differ greatly from card to card. Next, the secondary market. The marketplace is where individual MTG cards are bought and sold between players, collectors, and investors, outside of sealed products. These companies, TCG Player, Card Kingdom, Card Market, eBay, and Mana Pool, are some of the biggest when it comes to places where players can buy and sell their Magic cards, and therefore the sources of data from which the value of a card can be derived. Lastly, functionally identical cards. Two or more cards that fundamentally do the same thing, although their names differ from one another. To give you a concrete idea of what a functionally identical pairing looks like, take Colossal Dreadmaw and Bramble-Weft Behemoth. While their names, art, and creature types differ, their core gameplay mechanics, mana cost, power, toughness, and the trample ability are functionally identical. By matching these attributes perfectly, we can compare their secondary market trajectories directly. Here is another example with Cruel Bargain and Infernal Contract. Both are black sorceries with the exact same mana cost that force the player to pay half their life to draw 4 cards. Despite the phrasing being slightly different, they execute the exact same function in the game. And a final example is Short Sword and Honed Khopesh. Both are artifacts that cost 1 mana to cast, 1 mana to equip, and give a creature +1 power and +1 toughness. By finding valid pairings like these across the market, I can isolate the effect of a reprint on one card while utilizing its functionally identical counterpart as a market control. For these pairings to provide valid, generalizable insights, we have to establish a few underlying assumptions about the data. First, we must assume that functionally identical cards experience the exact same non-reprint related market forces, such as shifts in competitive relevance or format popularity. Second, we rely on the premise that pricing data aggregated from major platforms like TCG Player and Card Kingdom accurately represents overall secondary market trends. Third, we assume that the historical printing and card metadata pulled from Scryfall is complete and accurate. Finally, if these conditions hold true, we can reasonably attribute any significant divergence in price between the two cards solely to the introduction of a reprint. With those assumptions established, my methodology was broken down into 3 main phases. The first phase was grouping functionally identical cards to establish valid pairs where one was reprinted and the other was not. The second phase was pricing, which involved collecting the historical secondary market prices for these pairs at specified time intervals surrounding the reprint event. The final phase was processing, where I mathematically compared these price trends to quantify the true reprint effect. To execute the first phase, I utilized the Scryfall API, pulling their massive all-cards JSON file. Specifically, I downloaded a bulk data snapshot taken precisely on October 4, 2025 to serve as the foundational dataset. I then wrote a custom Python script to filter out digital-only and irrelevant cards, which aggregated the initial 93,384 printings down into a consolidated spreadsheet of 31,251 unique physical cards. From there, the script programmatically executed the grouping of functionally identical cards, successfully identifying 437 unique groupings. Of course, not all of those groupings were perfectly suitable for comparison, so I established strict criteria for pairing identification. Every pair evaluated had to meet a basic condition. It must contain at least one card that had been reprinted and one card that had never been reprinted. From there, pairings were assigned usability designations: yes, maybe, not really, or no, largely based on their initial print dates. To ensure similar market conditions, the best pairings featured cards first printed after the year 2012 and released within relatively close timeframes to one another. Cards printed before 2012 were often excluded entirely because they lack comprehensive, verifiable historical pricing records. Having successfully executed the grouping of our functionally identical cards, we then move into the pricing and processing phases. To determine the actual effect of a reprint, I employed a difference in difference, or DID technique, illustrated here in Figure 1. By capturing log-transformed price data 2 months prior to the reprint and comparing it to points either 2 months or 1 year after, we establish what is known as the counterfactual. The counterfactual essentially predicts what the reprinted card's price would have been if the reprint had never occurred by looking at the control card's trend. By subtracting this counterfactual from the actual post-reprint price, we isolate the unweighted reprint effect. However, an initial analysis of this unweighted data revealed a worrying discovery. Extreme random variance, especially among low-value cards, created so much market noise that a standard regression was unreliable. To properly isolate the impact of reprint events, the difference in difference framework relied on 4 key data points utilizing natural logarithms. We defined the natural logarithm of the secondary market price for the treatment card and the natural logarithm of the control card's price at time t, with t equals 0 set to 2 months prior to the reprint and t equals 1 set to either 2 months or 1 year after. As illustrated in Figure 1, the specific data points collected for each valid pairing consist of point A for the pre-reprint treatment price, point B for the pre-reprint control price, point C for the post-reprint treatment price, and point D for the post-reprint control price. For the third and final step of the pricing phase, all relevant price points were recorded based on the pre- and post-reprint dates identified for each pair. As shown in the comprehensive datasets here, 4 specific price observations were captured for every functionally identical pairing. These raw financial values were stored systematically in tables so they could later be converted into their natural logarithms, ensuring the data was properly formatted to calculate the true relative market shifts during the upcoming processing phase. With the pairing and pricing phases complete, the methodology moves into its third and final phase, processing. Here, the meticulously gathered historical price data is examined and compared. By analyzing the divergent price trends between the reprinted treatment cards and their non-reprinted controls, we can mathematically isolate and identify the true effects of the reprint events on the secondary market. To determine the actual effect of a reprint, I employed a difference in difference, or DID technique, illustrated here in Figure 1. By capturing log-transformed price data 2 months prior to the reprint and comparing it to points either 2 months or 1 year after, we establish what is known as the counterfactual. The counterfactual essentially predicts what the reprinted card's price would have been if the reprint had never occurred by looking at the control card's trend. By subtracting this counterfactual from the actual post-reprint price, we isolate the unweighted reprint effect. However, an initial analysis of this unweighted data revealed a worrying discovery. Extreme random variance, especially among low-value cards, created so much market noise that a standard regression was unreliable. To address this severe heteroskedasticity, I applied a weighted least squares, or WLS, approach. As you can see in Table 1, pairings involving treatment cards with initial values of 5 cents or less exhibited massive pre-WLS standard deviations, frequently exceeding 140%. To stabilize this, each observation was weighted by a multiplier derived from the square root of the treatment card's initial price, denoted mathematically as the equation to the right of Section B. Because the primary objective of a publisher's reprint is to decrease the price of high-value assets, giving these high-value cards more weight provides a much more accurate indicator of the true reprint effect, while preventing low-value cards from skewing the data. The short-term analysis revealed that a reprint event precipitates a statistically significant decline in the relative market value of the reprinted card. We identified an average negative 16.41% relative price change in the treatment group compared to the control group, and are 95% confident that the true average price change of all reprinted cards within the defined market parameters falls between negative 25.59% and negative 6.09%. The coefficient of determination for this model was 12.18%, which indicates approximately 1/8 of the short-term price variance can be directly attributed to the reprint event, while the remaining 87.82% of variance is governed by external factors, e.g. shifts in the competitive metagame, fluctuations in player interest, etc. With a p-value of 0.003064, the null hypothesis, i.e. reprints have no effect on relative value, is confidently rejected. Therefore, we can conclude that reprints have a measurable impact on secondary market prices in the short term. The long-term analysis did not identify a clear trend in the price of impacted assets. While we are 95% confident that the true average price change of all reprinted cards within the defined market parameters falls between negative 13.33% and 27.67%, this indicates the true effect could plausibly represent either a modest decline or a moderate increase in price, or nothing at all. The coefficient of determination for this model was just 0.4%, which indicates only a small fraction of the long-term price variance can be directly attributed to the reprint event, while the remaining 99.6% of variance is governed by external factors, e.g. shifts in the competitive metagame, fluctuations in player interest, etc. With a p-value of 0.602, the null hypothesis, i.e. reprints have no effect on relative value, cannot be confidently rejected. Therefore, we cannot conclude that reprints have a measurable impact on secondary market prices in the long term.
Based on the data we just reviewed, the implications are clear. Reprints affect the Magic the Gathering secondary market differently over time. In the short term, reprinted cards tend to see a decline in value, making the reprint effect significant, even though it is never the sole determinant of a card's value. In the long term, however, the reprint's impact disappears after about a year, becoming largely insignificant as the reprint itself holds little to no sway over the value of reprinted cards. This pattern is fairly consistent with previous research regarding the economics of MTG, where prior studies have found that reprints produce substantial short-term price declines, especially in high-demand cards. While the magnitude of the effect observed in the present study is smaller than previous estimates, the direction reinforces the belief that increasing supply decreases value in the short term, while changes in demand rather than supply determine value in the long run.
So, why does this effect fade? I hypothesize that the circulating supply of the reprinted card gradually declines over time, which completely mitigates the initial shock. In the short term, newly opened copies flood the market, increasing supply and dropping the price. But in the long term, not all of those purchased cards re-enter the secondary market. Many copies are kept in personal collections or active decks, effectively removing them from circulation and allowing the scarcity and price to stabilize. It is critical to acknowledge the limitations of this model. The DID framework assumes the treatment and control cards remain functionally identical in the eyes of the market indefinitely. However, over a full 12-month period, shifting competitive metagames might make the treatment card highly relevant, while its counterpart remains completely unused, severely lessening their correlation. Additionally, while the WLS method stabilized variance in the short term, the standard deviation for higher value cards in the long-term analysis remained at roughly 42%. This suggests that high-value assets become much more susceptible to outside factors as the initial reprint effect fades. In conclusion, reprints successfully execute their intended function. They act as a significant short-term supply shock that successfully lowers financial barriers and increases player accessibility. Simultaneously, because the effect is temporary, they accomplish this without permanently destroying the long-term market value of collections, which remain fundamentally protected by ongoing demand and game utility. Moving forward, future research should expand this framework to other collectible markets to see if these supply shock dynamics are a broader economic trend, and attempt to mathematically quantify the actual decline of circulating supply over time. These are my sources. Thank you for your time. Feel free to reach out and ask any questions. This project and its contents are copyright 2026, Nicholas J. Lehman, all rights reserved. Advanced Placement, AP, and College Board are registered trademarks of the College Board, which was not involved in the production of and does not endorse this independent project. Thank you.